pi, is known to be an irrational number, which means it cannot be expressed as a finite fraction or a finite decimal. The fact that pi is irrational implies that its decimal representation goes on forever without repeating. While we cannot directly prove that pi is infinite, its infinite nature is a consequence of its irrationality. The ancient mathematicians and scholars made significant contributions to the understanding of pi. One of the earliest approximations of pi dates back to ancient Egypt around 1650 BCE. The Rind Papyrus, an ancient Egyptian mathematical document, mentions a value of 3.16 as an approximation of pi. In ancient Greece, mathematicians like Archimedes, who lived around the 3rd century BCE, made substantial progress in estimating the value of pi. Archimedes used a method of exhaustion to find increasingly accurate bounds for pi. By inscribing and circumscribing polygons around a circle, he calculated that pi is between 3 and a seventh, approximately 3.1429, and 3 and 10/71, approximately 3.1408. Later, in the 17th century, mathematicians such as John Wallis and James Gregory developed infinite series that could be used to approximate pi. These series expanded the understanding of pi and helped mathematicians calculate its value to more decimal places. In modern mathematics, the proof of pi's irrationality was provided by Johann Lambert in 1768. Lambert showed that if pi were a rational number, it would imply the existence of a regular polygon with a finite number of sides that could exactly square the circle, a problem proven to be impossible by ancient Greek mathematicians. With the advent of computers, more digits of pi have been calculated using various algorithms. As of my knowledge cutoff in September 2021, pi has been calculated to over 31,415,926,535,897 digits, and it has been found to exhibit no repeating pattern. This further supports the notion that pi is an infinite and non-repeating number. While we can never know the exact value of pi in its entirety due to its infinite nature, mathematicians continue to explore its properties and search for new algorithms to calculate more digits.